So, is it going to go on anytime soon, or is it just going to show me my currently offline screen? Oh, looks like it's going. Okay. Hello everyone, this is Chris Ingerson. It is November 19th, and this is the November 19th TextQuest Dev Stream. It is Thursday, so we're going to be doing some programming, and we'll probably be focusing on a couple of random things. Some things that I think will be fun, some things that I think just need to happen, and I'll talk through them, but um, we will get to those in a second. Um, Currently, I am finishing up a bake of the light map for the lava level because I just did some quick mesh alterations to make the level a little more appealing. And we'll probably be doing a small script to make the lava slightly go up and down. That way it looks like it's actually sort of flowing a bit. It'll be a very, very subtle thing, but we'll be doing that tonight, as well as a couple of other miscellaneous things. Um, so, without any further delay, I need to tweet. Refactoring some code here, writing some new code involving lava there. Come watch. Yeah, that seems about right. Um, yeah, okay. I was one thing off from having my normal exclamation point, but oh well. Um, 19 jobs still. So we'll give this a couple of minutes, and I'll show you guys some other miscellaneous things that I've done so far, since I need to get in the habit of showing all my updates at the beginning of the stream. One of the things that I've done is I have completed. No, let me start over. I'm off the game tonight. So last stream we were doing some stuff with Substance where I actually made a custom, or I talked about making a custom library for the functions that we've built in the past. So stuff like oscillate over time and scrolling a float too. So I actually have those in my custom library now. So I have it set up to where whenever I'm working with Substance, I'll have these nice little functions that we've built in the stream. This is the oscillate over time one, and this is the float 2 scroll, which the float 2 scroll is the new name for what we were using to scroll the lava, and the oscillate over time is what we were using to fade the opacity of the emissive layer in and out. So this shelf will grow over time, hopefully, and it'll just be more and more fun trying to come up with new ways to get some animated materials on there. So that was a small Substance update. Because I'm really hoping that the last part of this light map's going to go fast. Let me pull this over. I have more or less finished the custom inspector stuff for interactive objects. So I can probably select them over here. So you'll see that we have a custom inspector for enemy information, including effective items. We can subtract and add with them if we need them, which most of this is parsing from JSON, so we shouldn't have to do that, but let me see. We have one for items as well. Not much information there. It's all just basic stuff. And of course, all the other ones that we already had. And what else have we done? Those are the big ones that I can think of. And then, yeah, once this light map finishes baking, which I'm hoping is going to happen in the next, we'll say 2 minutes, and if it doesn't, I'll just cancel it, and we'll continue on from where we normally would. Or actually, you know what? We can start coding. No reason why we can't. So let's go ahead and start working on a script that will bob the lava slightly up and down. So we want to basically have this. Where is it? There we go. The magma flow object. Of course, it's going to zoom me way out here. We basically want to have it move up and down, very, very slightly. So let's go to. Let's close all this stuff. So scripts, environment. Let's go to create folder, underground, create folder, magma river, and create C# script, magma flow. Alright, let's open this up. Yeah, reload all. I hate it when it does this. Hold on. Alright, I've also added some extensions to the screen, which is the screen is a class that Unity has built in that lets you reference your monitor's resolution and all of that stuff. And I've wrote a few extensions to it to make it easier for me to set up settings whenever you play the game for the first time. So what it was doing before, it was when the game was booted up for the first time, it would set its the game's resolution to be at the lowest resolution your monitor would handle. Actually, it wouldn't even do that. It would be set to 0, basically, which would, I assume, default to your lowest resolution possible. But that's a really, 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 really dumb thing to do. So now it actually, with that extension class, I have it setting it to your highest resolution of your monitor that your monitor will support. Currently, it's based on width. I probably will want to add something at some other point that lets you specify, I want this resolution. Because if you just base it on width, then a ratio of 16 by 10 will always beat out a ratio of 16 by 9. Well, most likely. So I'm going to have to mess with that a bit to make it actually work a little bit more like expected. But anyway, so this will be our MagmaFlow script, and it's going to be a pretty simple one. And I think what we're going to do is we're going to have a public float max y equals 1f. Oops. Public float min y equals 1f. And actually, we could do an no, we won't do a vector 2. There's no real reason for that. Let's do public float duration equals, say 5f, because we want the rising and falling to be fairly slow. And with that, we'll basically just have private IEnumerator start. So start is a built-in function to Unity, and what are you complaining about? Oh, right, because it's an enumerator. Hold on. Yield return null. I'll fix that in a second. Oh my god. Come on. There we go. So start is a built-in function, and it can actually be an enumerator. So it can be just a default void function if you want, and that's what most people use it as. But you can also specify that it's going to actually be a coroutine. So what we'll have our script do is at the start, it will start a coroutine that's just going to say while true, because we want this to always happen. It's going to go on forever. Let's get rid of that. Let's do float t equals 0f. And we'll do bool rising equals false. Alright, so while t is less than 1f, we're going to have your yield return null, rising equals not rising. So what we're basically going to set this to do, this is a very, very simple loop that we have it going on. We're going to tell it as long as, or at the very start, you're going to set your rising to be true. So it's going to start moving slightly up in the y-axis, and then once it reaches the maximum y that we set, it is going to set rising to be false. Then it will start descending down to the minimum y that we've set. And then it'll just keep going on forever because we have while true. And while true is just a very fast way to say always do it, because the while loop executes as long as the conditions are true, and while true is always true. So we'll say if rising, else. All right. So now, and at the very end, we're going to say, well, actually, no. This might be fine. No, it's fine actually. Just trying to think of the easiest way to not duplicate code. T plus equal time dot delta time divided by duration. So T plus equal time dot delta time means time dot delta time is a convenient way for Unity to say do this over 1 second. So if you have a speed of 5 and you tell an object to move at that rate, it will move 5 units every frame. But by multiplying it by time.delta time, which is how it's normally used, it will say move 5 units over 1 second. What we're doing here is basically the same thing, just sort of in reverse, because we're going to use our t value here to lerp our height. So we're going to be doing this, well, actually, transform dot position equals new vector 3, transform dot position dot x, then hold on, do 1f, and transform dot position dot z. Oops. All right. So we need to have float. No, that's fine. Float y equals mathf.lerp. Mathf is just a convenient library, or it's just a library inside of Unity that has a bunch of math equations in it. So we want to lerp between two numbers based on a normalized value between 0 and 1. So we're going to say min y, max y, t. So if our min y was 0, our max y was 1, and our t value was 0.5, the return value would be 0.5. If our min value was 0, our max value was 10, t at 0.5 would return 5. It's a pretty basic math function. And we're going to use that to set this. Alright. And we're basically going to do the exact same thing down here. The only difference is that we're going to reverse this order. That way, as we go down, or as time increases when we're supposed to be descending, it will actually lower as opposed to go up. Oh my god, it's still baking! Why is it still baking? Well, fortunately we're doing programming, so... Alright, do we have anything else to do in here? I don't think so. And that's essentially all we needed to do. We could potentially make this be based on the local position of the object at its start. Yeah, let's do that. That's actually better. So, I wonder if we could. No, it's fine. So we're going to do max y equals mathf dot max 0f max y. Then min y equals mathf dot min 0f min y. So what we're doing here is we're basically, instead of having max and min y be independent values, it's going to be based on the local position of the lava. So let's say our lava was at negative 100y for some reason. Having a max y of 1 and a min y of 0 as it is would snap the lava up to moving up and down between 0 and 1. But by making it based on the local position of the actual magma object, it's instead going to go only one above where the initial position of the magma is, and only, in this case, 0, because I have it set to 0, 0 below where the initial object is. So that means we're going to have a couple of private variables here. So private float. We'll call it start position, or start y. Start y equals 0f. And then we will set that in start. So start y equals transform dot position dot y. Oops. Had a parenthesis when I didn't need it. And all that means is when we do these lerps, we just have to have this. Start y minus min y and start y, oops, not enter, plus max y. Same thing down here. And start y minus min y. Bam. All right. Let this go. Screw it. Looks like the lighting's just not going to work. So, or it's going to take too long, which makes sense. The last time I built it, actually, which was last night, it was like 100 megabytes, which is huge for a light map. So we're just going to see what this looks like. Oh, I forgot to attach the script. All right, so let's just attach our magma flow here. Let's set our min y to be -1, duration to be 5. Okay, so now we should be able to see the lava actually popping up and down. Of course, we have to run over to it, but... no, it doesn't look like it's actually doing it. Okay. So let's take a look at this. We could also try, let's make this a really big number, like 10 and -10. And let's give it a duration of 1. So it should be fast and pretty noticeable now. Oh! Hello! Well, that's interesting. So it's That's curious. That's very curious. So it went up by 10, but was there an error? No. It just stopped for some reason. While t is less. I mean, I didn't. It's not stuck in a while loop. Otherwise Unity would freeze. Okay. Interesting. So, let's take a look at this. We're at max y is 10, min y is... Give it a duration of 5 again. Let's see if it slowly comes up, because it looks like it was just snapping up. Yeah, it just snaps up for some reason. Let's see. Yep. Just goes right up there. That's so weird. Okay. So, why is that, I wonder? So, we're doing a lerp between start y minus min y, which... aha! No. I was being stupid there. There we go. That's why. So, I was subtracting min y, but min y has to be a negative number. So, it was... When I was subtracting min y, it was subtracting a negative number, which gives you a positive value. That's why it wasn't moving, because it was just lerping between the same value, basically. So if I do this, we should actually get very extreme, but... Oh, and it launched me into the air. Okay. Let's just do 1 and 1, or 1 and -1. Alright. We gotta run over there. Looks like it actually is, so I'm gonna maximize on play. Yay! It's doing it! So we're getting that nice rising and lowering effect. Just to add some nice, it just adds some nice accent movement so that things don't look like they're static. Although chances are it's lava, so it needs to be a lot more viscous. So having it move like this is actually, like moving this fast is actually too much even. So just moving 2 units is too much. So if we drop down here. Yeah. But, hey, we got it working. That's all that really matters. So, let's adjust this. Let's make it like 0.25 and negative 0.25. Let's drop down so we can see a little bit better. Actually, that was a mistake. Hold on. Let me grab my guy. Because if we're on the actual lava, it's really hard to tell what's actually, how it actually looks. So, okay. So one of the things that's happening is you'll notice if you look really closely at the lava, it's linear interpolation. So that means that it goes from 0 to 1 or negative 0.25 to positive 0.25 in at the same consistency. There's no easing in or out of it. This is actually really jarring because nothing in nature moves that mechanically. So what we need to do is actually have a keyframe or have a animation curve. So let's have public animation curve. Not curving. Ease, I suppose, would be the logical. What should I call it? Let's call it interpolation equals new animation curve. And I think I can specify keys. New key frame. I think we want to do 0f. I always forget these. 0f, I believe. Then I can do the intangents, which I don't remember what. It's fine. We can just do the. And then 1f, 1f. Alright. So now we can do t times interpolation dot. Oh, there's a way to do this, and I forget what it is. Evaluate. There it is. Based on t. Actually, we wouldn't do that. We would just say evaluate. So interpolation dot evaluate t. Oops. So now, if we look at our script, we will actually have a curve to edit. Oops, that's the wrong object. Magma flow. So by default, we get this smooth curve, which is actually what we want because it's easing in and easing out. And what that means, easing in and out, is an animation term. So instead of, so this is what our current curve is. what we were doing originally was this, a linear interpolation. That just means that it goes straight from 0 to 1. There's no slowing down, no speeding up. It's just a mechanical movement. But with this easing in and out, it actually behaves more like something that reacts to physics. So, a key thing to know about movement is whenever you move, you don't immediately move in that direction that you were trying to move. You actually have what's called anticipation and build up. And basically, it means that instead of going from 0 to 1 right away, you actually have to go from like 0 to 0.1 to 0.25 to 0, yada, 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 all the way until you get to 1. And when you get to 1, unless you're running into a wall, most of the time you don't just stop hard at 1. You actually slow down and get to 1 naturally. So you'll see now if we look at our animation, it's not going to be just negative 0.25 to 0.25 all the way back down. It's going to be a slight speed increase in the middle and a slight slowdown or deceleration whenever it approaches any of the actual lerping points. Get up here. So as we go, you can see that it slows down a bit, starts speeding up, slows down a bit again, starts speeding up, slows down a bit again. It's a very, very subtle change, but it's what's expected. That's actually how objects in nature behave. So, anyway, so that's pretty much all we got to do for that script. Okay, knocked that out early. The next thing we can work on, close all that, save, is, we have a couple of things that we could do. One is, well, we have a big thing and smaller miscellaneous things that we could do. The big thing would be coming up with a mini game for the loading screen. I kind of want to hold off on that actually until I get TextMesh Pro implemented, and I'll pull that up. I think I've shown it before, but it's always good to cover bases for people who haven't seen it before. So TextMesh Pro is a Unity asset on the asset store. Well, it's an asset on the Unity asset store. It's not made by the Unity guys, but TextMesh, if I could spell. And it's basically just this really, really fancy text rendering plugin. So it has a lot of really, really nice additions and effects that you can do. And it's also just nicer text in general than Unity's built-in text. But I want to wait till I get this implemented into the game to actually start working on that text. Anything involving text heavily, like the UI stuff anyway, just because I don't want to try to make it work for Unity's text component, then have to adjust it completely to use this text component, which from my experience with this in the past, it wouldn't be that hard to actually port it, but still I would prefer not to have to port it at all. So until I get that actually implemented in, I'm not going to work on that minigame, I think, unless there's just overwhelming demand for it, but I think it's fine for now. So the next thing we can do is, let's go to scripts, and this is going to be fun. We're not gonna mess with the parser right now. There are some things that I need to do with the parser, just because there are one or two slight bugs that I don't like. They're not major, but they're annoying. Oh, actually, what we can do is, let's go to scenes real quick. Go to intro, castle quarters. Let it load. Alright, so if we were to play, we'll get dumped into the scene at the beginning. And I want to try something. I don't actually know if this bug is fixed or not. We're going to type some gibberish here at the end. Oh, no, that actually might be good. Okay, never mind. So we don't have to fix that. I already fixed it. I wasn't sure if I got rid of that. So originally there was some bug where as you started typing, so if I was going to say take the, I don't know if it's got, yeah, it's not a, oh wait, yeah, okay, that's a bug. Um, so originally there was some bug that basically if your text, I'm going to say the a take painting. So you'll notice that my input is now longer than the original string allowed for, and that's fine because it just goes off the screen. But originally there was a bug that would basically trim the input to make it so like this would actually be cut off and it would say the take pain, and then it was like, oh, there's no pain around here. So that's nice that we don't have to fix that. Okay, well that took the steam out of my sails for a bit. Um, wow, that was two completely different metaphors. Okay. Um, hmm. Well, if that's the case, then hooray! So it's going to be a little bit of a mundane thing today, unfortunately. We will focus on. Oh, we can close that. We don't need it. Um, oh, we don't need the interactive object inspector either. Let's go to say door. Or actually, you know what? Let's be bold. And let's go to enemy. Okay. So I need to refactor how some of these older scripts work. Because a lot of these interactive object scripts were written, a year and a half ago, probably. Um, so currently, let's go to one of the later levels in the overworld. Heroes Grove. No, not Heroes Grove. Not Woods. It's going to be fun. Fog. Actually, it's held up a lot better than I thought it would. Okay. I don't know if this is going to let me start playing or not. Oh, it does. Good. Um, so let me drag my player all the way over here. Oh, I was eaten by a Gru. Of course I was. Let's try this again. So this is a level from later on in the game, and this. One of the things that happens here is you actually meet this giant spider. So currently, yeah, it's just going to say that. But if I say hit, say your attack is ineffective. Hit, your attack is ineffective. Yeah. Crap, I didn't mean to do that, but it's fine. Let me get the sword. So the idea is that you actually... is that you actually need to use a weapon, not just your bare fists, to try and kill something. Or at least most things. So you won't be able to kill the spider to get a treasure that it's protecting until you have the necessary weaponry. Roll you all the way over here. Roll you over here. Go up. Alright. I should be able to take this. Ah, crap. Yeah. Ah, dang it, I keep not meaning to hit Control P. I keep meaning to hit Control Shift P. It's fine. So let's just change this stuff. Add to inventory. And that's all fine. Ah, dang it. I gotta fix that. But for now, it's fine. Take outputs, obtainable items. So my custom inspector isn't 100% great. Actually, I don't need to do that at all. Let's go back here. So this should all be fine now. So if I play, then pause. Now when I take the sword, the sword's outdated right now. That's why I was saying I don't understand that sentence. Up, up. Oh, good. Oh, we got a null reference, which that means everything's fast. Brah! Freaking. Why? Well, fun. I suppose that we could take care of this real quick. Because of course we will. So, let me pull this up. Make a sword info, and then we will populate the sword data with that. Oh, not programming. That's just what the topic is for today. Design, interactions. Let's make an interactive object template. Make a copy of that. Alright. Then we will need to go to Heroes Grove. That's where you get the sword for the first time. Copy this into items. Alright. So let's rename this old. Come on. Alright. Heroes sword. So we're going to copy all this. Ignore groups false. Let's go over to item, because it is an item. Let's copy these two things. Bam. Go to verbs. And let's, oops. Oof, that would have been bad. Copy these over to our verbs over here. That was kind of pointless. These are all going to be that. Let's copy these. Move this so that's a default fail. And then, of course, let's highlight this all and make sure that it wraps. That is a terrible pun. No one's going to get that. Reset and interact, all this stuff is fine by default. Don't have any of that. Don't have required items, don't have obtainable items, don't have item or word checks. So this we should be fine here. Let's go to File. Add-ons, export sheet data, open sidebar, go to JSON, all sheets, replace. No, you don't need to do that. Unwrap single row, export cell arrays, export sheet arrays, and export. Let that compile. And I'm just curious how good it does. Let's download this. Then we will be able to bring it into Unity. Let's go to data, interactions, interaction data, overworld, Heroes Grove, items, Heroes Sword. Get rid of all of this crap, because we don't need that. Oops. Let's go to game development, SPC, downloads, Heroes Sword JSON. Sword folder too. Alright. I don't remember if I fixed... dang it. I was worried about that. What do we got? Item check. Yeah. Wait. What? It shouldn't have any item checks unless I had one in there by default. Item checks. Yeah, there's nothing in there. Why are you complaining? Hold on. That's curious. Ah, I know. I think I know why. Right. Well, that's problematic. So, well, let's just do this then. We'll do custom. We'll only export the ones we need, which would be info, verbs, and item. We don't need anything else. So, and we will replace existing files. So we'll export again. Let's open this up. Let's download this. And then let's try this again. Ta-da! I hope. Info, silver, names, hero, sword, sword, blade, edge, brand. Okay. Swords, blades, edges, brand. Really? Brand, not brands? Okay. Ooh, and legendary. Item info, it is a hero sword. Ah, I gotta set that too. Okay. Equipable. That's odd. I wonder why it didn't. Anyway. It's not a light sword, its weight is 2. That's fine. Take. I'm assuming that all of this is going to be fine, so now let's try it again. See if everything breaks. Or if everything works. Let's pause. Go to hero. Move me over here. Move me up slightly. I just have to remodel this entire place. There we go. There we go. I don't even know if this will work. Hit with sword. So currently, that's how you do combat. And actually that was a really bad example because I got it on the first hit. The actual combat in this game is kind of inspired by well, not kind of, it's entirely inspired by the original Zork, which is this terrible, terrible combat system where hopefully it'll do it this time. So let's take this. I don't even think I have to have it equipped, actually. So if I hit, it doesn't do anything because, you know, using your bare fists don't work on the spider, so you have to say hit with sword. Oh, it's doing it all the time now. Well, let me adjust those values then. Environment, level, props. Really? Come on. Yarg! Alright. So our giant spider, enemy info. So by default, it has a 25% chance that whenever you hit it, the enemy will get stunned, and a 10% chance that whenever you hit it, it will just instantly kill it. So if you don't get either of those things, the spider's just going to dodge your attack, and in theory, that could happen enough times that people will think that they can't kill it. So if I were to, say, adjust this to be a stun chance of 10, and a death chance of 1. This might be a little closer to what I was hoping to show. Because I think I did balance it pretty heavily so that it was unlikely that you would ever really get that. But that's not really fixing the combat problem, it's just masking it. Let's go back here. Take